Exercise 6.5, we continue with the fourth question here. Prove that the following functions do not have maxima or minima. That means there should not be any turn in the graph of this function. This is turning point, this is turning point, this is turning point, and so on. So which is not there obviously, but we'll prove with the help of derivative. What is f dash x? E raised to x. What is f double dash x? Again e raised to x. Now clearly clearly f dash x equals to e raised to x, which is always positive. You know this never be 0. Therefore function f has no maxima as well as minima. You know, if function has a maximum or minimum value, then its first order derivative is always 0. But here first order derivative is always positive. In fact, this being positive, it's an increasing function. You know graph of this, recall continuity and differentiability chapter. It's an increasing function, graph goes up always. Okay. Second question, fx gx equals to here, you have log x. What is g dash x? You know 1 upon x, where x should not be positive. And domain, it is understood here. Domain of log function is always r plus. You know it, right? In proper domain means it should be here r plus. So here, this being positive, g dash x is always greater than 0 for every x in the domain, r plus, positive real number. What's the meaning of this? That means again here function g has no maxima as well as minima. No maxima as well as minima. It is again, you see, this being positive, it's an increasing function. So it will never have such turns. Right? To have maxima or minima, the graph of the function must have certain turns like this, turning points. You know, graph must have such turning points. You know the graph of log function, it has no turning point at all. It's an increasing function. Okay. Next question. You have a function hx equals to x cube plus x square plus x plus 1. Now here from the graph it's very difficult to observe. In previous two questions you can answer from the graph itself because both were standard functions. This is not the standard function, it's a polynomial function. Look at it, its first derivative, 3x square plus 2x plus 1. This is quadratic. And you know every quadratic can be expressed as a sum of the difference of the two perfect squares, you know from integration. I'll make the coefficient equals to 1, so dividing by 3. Okay? I'll write here 1 by 3, dividing by 3. Fine. Now, you know, to make it perfect squared, how do we get the last term? Divide by 2 and square it. So if I divide this by 2, it will be 1 by 3. So if I square it, 1 by 9 minus 1 by 9. Okay. Now this much is a perfect square. 3 into here x plus 1 by 3 the whole square. Such things you know very well from integration. What's the simplification of this? Take 9 as LCM. So here by 9, so 3 minus 1. So you have 2 by 9. Now what about this bracket? What about this bracket? It is always positive. Even this is 0. It might be 0 at minus 1 by 3. But this being positive, this being positive, this is always greater than 0. So this is again increasing function. So therefore h has neither maxima nor minima. Neither maxima nor minima. Nor minima. Clear? Okay. Let's go to next question number. Next question number 5. Find the absolute maximum value and absolute minimum value of the functions given below. Define on the closed interval. Here you are not asked local maxima or minima. So let's see. This is based on the theory just we have completed before starting this exercise. So it's based on this theory. Function defined on the closed interval. So what we do, we get the turning points, and then for absolute maxima we'll get the maximum of all local maximum value f of a, f of b, and for minima we take the minimum of all local minimum values f of a and f of b. This concept we are going to use here. Okay, so let's see this. 3x squared f double dash, it would be just 6x. Fine. Now you know for f dash x equals to 0, it implies 3x squared equals to 0. It means x equals to 0. So here this is a critical point, turning point. At 0 function has one turn, so is a critical point. Critical point here. Critical point means what? Either it has local maxima or local minima. Now when function is defined on an interval, you need to get the values at these two endpoints. What is f of minus 2? Minus 2 whole cube. So it will be here minus 8. And what is f of 2? It will be 2 cube, which is 8. Okay. And now at critical point the value of the function, that is 0 cube, it will be 0. Now absolute maximum, that is the highest value of the function in the entire domain. Absolute maximum value of f equals to maximum of the points where the function has a turning point. Here you have not asked local maximum or local minima. That's why you have not decided whether it has a local maximum or minimum. But just we have decided that that's a turning point. So one is this value of the function at critical point, that is 0. Right? Then minus 8 and then plus 8. What's the maximum of all this? That is 8. And where this value is obtained, it is at 2. Fine. You are asked just for absolute maximum value, and this is obtained at x equals to 2. So this is a point where the function has the maximum value, and which is 8. Okay. And now absolute minimum value here. Absolute minimum, I'm sorry, here I forgot to write absolute maximum value. Here minimum value of f equals to minimum of which three numbers? Critical point, that is 0, and two endpoints, which is minus 8 and plus 8. So minimum is minus 8, and it is obtained at which place? At minus 2. Fine. So it has minimum at minus 2, and where this value is obtained, that's minus 8. You are just asked for absolute minimum, which is minus 8, and absolute maximum, that's nothing but at 2, which is 8. You are not asked for local maxima or minima. That's why we are not decided whether 0 has a local maximum or local minimum, remember. So just for your reference, not for examination point of view, graph of this cubic function from minus 2 to 2, roughly it's like this, if you just remember here. So at 2 it has highest, which is 8, it comes from here. At minus 2 it has the lowest, which is at which place? That is here at minus 2, and minimum value is minus 8. This is minus 8. And this is plus 8. At 2 it has a maximum value, so this is sometimes called the global maximum, which is 8, and global minimum, which is minus 8. Just for your reference, graphical behavior. Okay, next question. There you have sin x plus cos x. Second one, this is really nice question. You have fx equals to sin x plus cos x. On which domain? On 0 to pi. Okay, fine. So what we'll do here, we just differentiate it. Once we find the critical point, Okay, so let me differentiate it. This is cos x minus sin x. Double derivative is not required still if you want to do, because we are not going to decide the local maxima or local minima. Double derivatives you required when you want to get the local maximum or minimum value. This is minus sine and this is derivative of sine is cos. You doesn't require especially in this solution, but still I did it for you. Okay, now you know for f dash x equals to 0, it implies cos x minus sin x equals to 0. Okay, so you know very well that means tan x equals to here 1. Here domain is 0 to pi, first two quadrants. You know here all are positive, here 10 is negative in the second quadrant. That means you have just one critical point. Is it? Am I right? Which quadrant? First quadrant only. And therefore what's that critical point? You know x equals to pi by 4. Right? This is a point where the first order derivative becomes 0. So is which point? Is a critical point. Is a critical point. You know very well now, critical point. Okay, if you have confusion, just revise the theory. I'll need to get the value of the function at pi by 4. So for pi by 4, just place here, that is 1 by root 2 plus 1 by root 2, which is just root 2. Fine. Then function is defined on an interval, so I need to get the values at f of 0. Sin 0, 0, cos 0 is 1. So this is 0 plus 1 is just 1. F of pi. Again, sin pi is 0 and cos pi is minus 1. So we have minus 1 here. Now as I did, therefore, absolute maximum value of function f, that's equals to maximum of all points where the function has either local maximum or local minimum. That is, I am asking for critical point. What's the value of the function there? Root 2. F of 0, 1. F of pi, minus 1. Get the maximum of this, which is root 2. Highest, 1.41. And this is at which place? Root 2 is obtained over here. This was in fact the local, local value. But anyway, at pi by 4. And last one, that is absolute minimum value of f, that is equals to minimum of, again, critical point and two endpoints, that is root 2, then you have 1 and then you have minus 1. So what's the minimum? That's minus 1. Where the minimum is obtained, that's 1 point at pi. This is not important, just for your reference I'm writing. Okay, so here absolute maximum is given by, what's the absolute maximum value here? That is nothing but root 2. Absolute maximum value is here root 2. And what's absolute minimum value? Which is minus 1. If I just draw the graph, rough graph, for your clarity, not for examination point of view. See, here 0, for example, this is pi over here. Pi by 4 is somewhere here. Okay, what happens at 0? At 0 the value of the function is 1, somewhere here. Okay, and it has pi by 4 highest, so this is the highest point. This is the highest point. So like this graph goes up. And what about at pi? It has value how much? Minus 1. Then graph may come down like this here. Right? So roughly behavior is this. This is the lowest value in the entire domain, and that lowest value is here, minus 1. This is in fact the local maximum. Now look at that graph. But the highest value is obtained here. So this is minimum at pi, and global maximum or absolute maximum is here at pi by 4. That's what we have noticed. So graph is roughly like this, highest. In fact, this is also known as local maximum value, but that we have not considered here because we are not asked in the question. Okay, let's go to next. Third and fourth both are about polynomials. I'll do just fourth for you. Okay, so their function is x minus 1 the whole square plus 3. On which domain? Minus 3 to 1. Okay, in this domain you want absolute maximum as well as minimum value. So what we'll do, we just differentiate it once. Okay, so let's differentiate it. So you have 2 times x minus 1 into 1 by chain rule. This is 0. You doesn't require double derivative here, so I'm not doing that. Now for f dash x equals to 0, it implies you have 2 into x minus 1 equals to 0. So x equals to 1. And this is nothing but which point? A critical point. A critical point. That means at this place, function has either local maximum or minimum. That is known as critical point. But we, as emphasized on earlier sub questions, we are not going to decide whether it has a local maximum minimum over here, because that's not asked in the question. In fact, for that you need double derivative also. Okay, now we find f of 1. We need the value. Put 1 here, so this will be 0, so it is just 3. Fine. Okay, what about f of minus 3? This is in fact the endpoint. You see here. What is f of here? Minus 3. Let's put the minus 3. So if I put minus 3, it will be minus 4. So 16 plus 3, so it will be 19. And f of 1 is this endpoints. Okay, so now therefore absolute maximum value of f equals to maximum of, right, turning point, that is 1, that is 3, and that is itself one of the endpoint, and the other one is 19. So highest is 19 here, and where it is obtained? At minus 3. Fine, so here it's like this. Okay, so absolute minimum value of f is minimum of turning point, that is 3, and 2 endpoints. Here the same endpoint you are having, so 19, so which will be 3. And where it is obtained? That 3 is obtained at 1, right, over here. Fine, so absolute minimum is 19, which is obtained at 1, and here absolute maximum is 19, and which is obtained at minus 3. Here 3, which is obtained at 1. So here you are given a profit function. You are given a function. That's not important whether it's a profit function or not. You are asked for maximum profit. So it is understood here function is defined on R. Closed interval you are not given as a domain. That means indirectly you are asked for what? Local maximum. It's understood from the question. This is what indirectly you are asked. Whenever you are asked for absolute maximum or minimum, the domain should be an interval, as we were discussed in the theory, you know very well now. So how many times we need to differentiate it? Twice. Constant derivative 0 minus 72, here 36x. Again differentiation, double derivative 0 minus 36, because here it is 1. This is negative. Double derivative is negative, means function will have always maximum value. Okay, now for first order derivative equals to 0, it implies we have minus 72 minus 36 equals to 0. So you have 72 equals to minus 36, and therefore x equals to here minus 2. Right? And double derivative is always p double dash, even if I put minus 2 or any number, this is always negative, minus 36, this is fixed. What is the meaning of this? At minus 2, first order derivative is 0. At minus 2, second order derivative is 0. Therefore, at x equals to minus 2, p has negative means maximum profit. Okay, function has a maximum profit. Okay, and how do you find that maximum profit? Maximum profit equals to, how do we get it? Just put minus 2 in the function. So p of minus 2, you know, f of c if you remember. So I'll just put minus 2 in the function. 41 plus 72 into 2 minus minus gives us plus 18 into 4. So 41 plus 72 into 2, which is 144, minus here 72. So we are just left with 72. 41 plus 72. So this is 3 and this is 11. So this is the maximum profit, 113. 113 is the maximum profit. It is in fact, what's that? That is a local maximum value of the function, where the function has local maximum value at -2. Seventh question, you are given this polynomial which is defined on closed interval 0 to 3. So this question is just based on which question? Question number 5. So refer fifth question. We did the 3 sub question, right? Just based on the solution. Flow of the solution is same. What you need to do? Find f dash x, find f double dash x, put f dash x equals to 0, so we'll get the x, that is, here critical points, point or points, whatever it is. Then here no need to decide whether it has a local maximum or minimum value. So in fact this is also not necessary here. Then find over here, suppose this is c, find f of c. Then at 2 endpoints, find f of 0, find f of 3, right? Get these 3 values, then decide the maximum and minimum among these 3, as we did where? In the question number 5. Just copy of that question, so I'm not doing this. Okay, 8th question, question number 8. What about 8th question? At what points on the interval 0 to 2 pi does the function, okay, you have fx equals to sine 2x. What's the domain of the function? 0 to 2 pi, closed interval. What is the question here? Question is, get the points where the function attains at highest value on this closed interval 0 to 2 pi. That is the question, right? Okay, so let's see that. Okay, this is also a nice question. Let's differentiate it here. So we have 2 times cos 2x, chain rule, f double dash x, that is your minus, again by chain rule, sine 2x. Okay, now for f dash x equals to 0, this is for turning points. You have 2 times cos 2x equals to 0. That means cos 2x equals to 0. Now you see, instead of this is domain, it is understood for 0 to 2 pi. Here it is for 2x, now domain becomes 0 to 4 pi. Right? Angle is doubled now. That means you have 0 to 4 pi as a domain. That means how many rotations around the unit circle? 2 rotations. 1 and then 1 more. Okay. Now where this cos becomes 0, these values you can write very easily. During the first round it is pi by 2 here. Then here 3 pi by 2. This is 1 rotation. Now during the next rotation, angle will be increased by 2 pi because period is 2 pi. So 2 pi plus pi by 2. The same value, just I'm adding 2 pi. And then 2 pi plus 3 pi by 2 during the second round. Fine, I hope these two are clear to you. So therefore, what are the values of x dividing by 2? Pi by 4, here 3 pi by 4, here this is 4 plus 1, so 5 pi by 4, here 4 plus 3, that is 7 pi by 4. These are the values of x here now in 0 to 2 pi, for which this cos 2x becomes 0. These are all nothing but which points? Turning points or critical points. These are the turning points, Okay, so all at these 4 points, either function will have maximum value or minimum value. I repeat, at these points, either the function will have maximum value or minimum value. So that we don't want to decide, we want to get just highest value. So what we'll do, we put this one by one all values in the function. So we'll find f of pi by 4, then we find f of 3 pi by 4, then we find f of 5 pi by 4, then we find f of 7 pi by 4, and two endpoints, which is f of 0 and f of 2 pi. Fine. We are not asked for local maximum or local minimum. That's why we are not deciding whether at pi by 4 it has a local maximum or minimum. Remember, the question should be clear to you. We are just asked for maximum value of the function. Now what is f of pi by 4? That is 2 into cos pi by 2. 2 is there, so this is 0. Am I right? Cos, if I place there here pi by 4, then we have, sorry, this is my mistake, I placed in f dash. You are going to put into the function. So 2 into sine 2 into pi by 4. So it will be sine pi by 2. You know that this is 1, so here it is 2. Now 2 into sine, there into 2 is there, so it will be just 3 pi by 2. What is sine 3 pi by 2? You know it is here. Again, I'm sorry why I placed 2 here. This is just 1. 2 is not there. This 2 is not there. So this is minus 1. Okay. What about next? 5 pi by 4. So you have sine, you know here 5 pi by 2. Right? Why 5 pi by 2? Because into 2 is there. And you know, you can just check, this is just 1. It's at this place, sine 7 pi by 2. You can just verify that this is minus 1. At 0, this is just 0. At 2 pi, again this is, you know, 0 because it becomes 4 pi. So function has highest value 1, which is at pi by 4. This is also highest, which is at 5 pi by 4. So alright, function has maximum value. This is in fact absolute maximum at x equals to 1 is at pi by 4, this one is at 5 pi by 4. So pi by 4 and 5 pi by 4. These are the points where the function has the maximum value. And what's that maximum value? It is 1 because it is a sine function obviously. So the maximum value will not be more than 1. The ninth question, this is also an important question. What's the maximum value of the function sin x plus cos x? Now here, like previous question, interval is not given. Okay, so in fact you know that the range of this one is minus root 2 to plus root 2 from 11 trigo. You know very well. So highest value will be this only, and this is the lowest. If it is asked in MCQ, you can write it directly. But here as a subjective, we'll do with the help of differentiation. So f dash x will be what here? You know, cos x minus sin x. Fine. Now here double derivative is not important because you are asked for highest value. Double derivative is important only when you are asked for local maximum minimum. So we'll just get the turning points. So for f dash x equals to 0, it implies cos x minus sin x equals to 0. Take 1 on the other side, so we'll get the tan x equals to 1. Now in previous question, domain were an interval. Here domain is not an interval, so you need to recall the solution of this tan function, which is, you know, n pi plus the angle for which tan becomes 1, which is pi by 4. Right, where n can be here any integer. N can be any integer, you know, n belongs to that. This is a solution of tan x equals to 1, 11th standard. Why we have written general solution here? Because domain is not given. So there are number of points where you know, this function has a local maximum or minimum. These are called turning points. These are nothing but what? Turning points. Obviously sine plus cos you are having, so you have a number of turning points. Now if for example n is 1, then pi plus pi by 4, third quadrant. And if n is 2, then it will be first quadrant. So we divide into two cases. N is even and n is odd here. Right? So if n is even, like 0, 2 pi, 4 pi, then it will be always in the first quadrant. So you can write, if you want, 2k pi plus pi by 4. Which quadrant? First quadrant. If it is odd, like pi 3 pi, then it will be in the third quadrant. So you can write, if you want, 2k plus 1 pi plus pi by 4. Even and odd. This is odd number, this is even number. Okay. Now to get the maximum minimum value, where we put this in the function, directly in this. Okay. So f of x over here for this value. Now you know 2k pi is a period, so this looks like 0 for sine and cos, you know. So it is just sine pi by 4 plus cos pi by 4, which will be 1 by root 2, 1 by root 2. So it will be root 2. Fine, that is this value indirectly. Now over here, this is like pi, 3 pi, 5 pi. Every time it is in the third quadrant. This is negative, this is also negative. So what is fx here? In the third quadrant, both are negative. So this is minus 1 by root 2, this is minus 1 by root 2. So here value will be minus root 2. So what's the conclusion from this? What's the highest value of the function? Highest value is this root 2. And where it attains, it is at all these points. 2 pi plus pi by 4, 4 pi plus pi by 4, 6 pi plus pi by 4, and so on. So I'll write final concluding line. Right. So the maximum value of fx, that's the given function, is how much? Root 2. You are asked this much only, where it attains at x equals 2. This is just for your reference. I'm writing 2k pi plus pi by 4. Right? This is for your reference, where k belongs to z. This is not asked in the question. Question solution is over here. The maximum value is root 2. You were knowing from the beginning, but we did with the help of what? Derivative here. Okay. Next question. Again, I think it's simple standard polynomial function, and now the domain is an interval. 2x cubed minus 24x plus 107. There are two sub-questions. In one question, domain is this one. In the other question, domain is this, minus 3, minus 1. Okay, this is just for your reference. Question number 5. We are again doing fifth question. It's like that only. Okay. You are not asked for local values, so double derivative is not important. We just differentiate it once. So we have 6x squared minus 24, right? Why double derivative is not important? Because in the question you are not asked for the local maximum and minimum values. You just need to get what here? Maximum value and minimum value, as we did in the fifth question. Flow of solution is like fifth only. Now for f dash x equals to 0, it implies 6x squared minus 24 equals to 0. So x squared equals to 4. Now here domain is, for the first sub question, domain is 1, 2, 3. That is x equals to 2 only. When you do the second one, then this is same, but for the second sub question here, domain will be minus 3 to minus 1. So there it is minus 2. Understood? For the second sub question. So at one place 2, the other place minus 2. If you combine both the questions. Okay. Now what we'll do? This is turning point, remember. This one is turning point. This is also turning point. Both are the turning points. Either at this place it has a local maximum or local minimum, and similarly over here. But that we are not verifying, whether it has a local maximum over here or local minimum over here, because that's we are not asked. And here domain is an interval, you know. So for this, now what you need to do, you need to find f of 2, put into the function. Fine. Then if you are doing first question, f of 1, get this, then f of 3. Okay, got it? Now here in the question you can see, find the maximum value in 1, 2, 3. So here you get the maximum of all the 3. So the maximum value you can write, you know, absolute maximum value. That's the maximum of this one, and the third one from this. That's the maximum value. Okay, that much you can do. Now I'm sure it's not a big task. Okay, the next part over here. So when we are doing for this, same procedure. Here f of minus 2 as we did here. Get this value. Here domain is this. There the domain was 1, 2, 3. Then they get f of minus 3. Put minus 3 in the function. And the minus 1 also. Get these 3 values. And then, like the previous part, what you have to do? Write the maximum value equals to maximum of this value which you got a turning point, and these are the two end points over here and over here, right? Decide the maximum of this, so that gives you the maximum value over here. In 11th question, you are given that this function has a maximum value at x equals to 1. So what happens at 1? First order derivative must be 0. So therefore f dash 1 must be 0. We use this. So first we get f dash x, and then we put x equals to 1, so derivative must be 0. And at 1, double derivative has to be negative, but that's not important for us. Let me differentiate this. 4x cube minus here, this is 124x plus small a, this is 1 and this is 0. So f dash 1 equals to 0. Why? Because if function has maximum or minimum value at a point, then the first order derivative is 0. This is turning point. Okay, so I'll just put here 1. So 4 into 1 cube minus 124 plus a equals to 0. So therefore a must be 120. This is a required value of a. Okay, so question number 12, which is also very important question. There you are asked maximum and minimum values of this function on closed interval 0 to 2 pi. You are given the domain. This is just same as question number 8, which was also very important. And 5th second. Okay, so what we'll do? We are not asked for the local values. So we just need one derivative. F dash x equals to 1 minus, by chain rule, derivative sign is plus. So twice cos 2x. We doesn't require double derivative here. Now for turning points, for f dash x equals to 0, it implies 1 plus twice cos 2x equals to 0. So from this, what we'll get? Cos 2x equals to minus 1 by 2. But now being this double angle, your domain becomes 0 to 4 pi. Okay, and how many rotations? 2 rotations around unit circle. 1 and then 1 more here. Okay, now the first thing you need to ask yourself is here, where this become minus 1 by 2. That means cos is negative. Here positive, here positive. So either this quadrant or this quadrant. Second quadrant means pi minus something. So here 2x equals to pi minus, for what value of the x, cos x becomes 1 by 2. It is nothing but what? Pi by 3. So pi minus pi by 3. Here pi plus pi by 3. Got it? And during the second rotation, when you complete one rotation, when you start the second rotation, then angle will be plus 2 pi. So this angle plus 2 pi. So it will be 3 pi minus pi by 3. And here 3 pi plus pi by 3. I hope this is clear to you, because this is the second round. So angle will increase by, in the first round here it was pi, but then it becomes 3 pi. Okay, now let's simplify this. This was 2x, but now I'm writing x. What is this? 3 pi minus pi. 2 pi by 3 by 2. So you have just pi by 3. Here you have 4 pi by 3, but when I do by 2, that is 2 pi by 3. This is 9 minus 1, 8, but when I do by 2, it is 4 pi by 3. This is 10, when I do by 2, it is 5 pi by 3. So these are the 4 angles where first order derivative becomes 0. Okay, so now what we do, as we did in 8th question, we'll not decide whether it has a local maximum or minimum, over here or not. We put these 4 values, 2 endpoints in the function, and we'll see where it has maximum or minimum. So we find now what we'll find, f of pi by 3, right? Then f of 2 pi by 3, then f of 4 pi by 3, then f of 5 pi by 3, and then those 2 endpoints, be her function is defined on the closed interval, and f of 0, this is one endpoint, f of 2 pi. Okay, so f of pi by 3, what is f of pi by 3? Just in the function, instead of x you put pi by 3. So I'm just putting there, so we'll get the pi by 3 plus sine 2 pi by 3, because 2 is already there. So this is pi by 3 plus root 3 by 2. You can just verify, this is second quadrant, pi minus pi by 3 and so on. From trigo you know, right? This is roughly pi by 3 is 1 point something. This is 0.87, so it will be 1.92. You can just check using calculator. Okay. What about this? Here it will be 2 pi by 3 plus sine, it will be 4 pi by 3. So pi plus pi by 3. Now it will be in the third quadrant. So what we'll get from this? Here, from this we will get here how much? 2 pi by 3. This, because of the third quadrant, you have minus root 3 by 2. So it is again 1 point something, you can check. Okay. 4 pi by 3 we are just putting. So 4 pi by 3 plus here sine of 8 pi by 3. Right? And which you can just verify. This is again in the first quadrant. So you have 4 pi by 3 plus root 3 by 2. 4 pi by 3 plus root 3 by 2. So I suppose here it will be pi by 3 was 1 point something, and here roughly you can just verify it is 5 point something. Now let's come at 5 pi by 3. So here you have 5 pi by 3 plus sine of this is 10 pi by 3. So it will be 3 pi plus something. So it will be in third quadrant. So this is minus root 3 by 2. This much you can do. This is 3 pi plus pi by 3, third quadrant. So here it would be 1 by 5. So it is 4 point something. Right? Just roughly. Now at endpoints, 0 plus sine 0. It will be 0. At 2 pi plus here sine 4 pi. This will be 0, so it will be 2 pi, 3.14, so it is 6.28 roughly. Okay, so what's your conclusion from all? Where the function has the highest value, that is at 2 pi, and which is 6.28, and which is also obtained at this one. So I'll write the maximum value of given function equals to 2 pi, or this roughly. And you are asked for minimum value also. What's the minimum of all this? Minimum value of f equals to 0 here. If you want to write maximum value 2 pi, which is at 2 pi, this is just for your reference. Minimum is 0, at which place? At 0. Okay, so here, not for examination point of view, for your information, this is 0, this is 2 pi, right? So from 0 to 2 pi, there are how many turning points? 4 turning points. 1, 2, 3, 4, these points, right? Function has these turning points, but the lowest value is over here, which is this. Then it may be like this, here, like this, but at 2 pi, again it attend highest like this. Understood? This is, for example, pi by 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3. These are all turning points, right? These are nothing but which points? Critical points, you can call. critical points or turning points where the function may have, local maximum or minimum, like this, here, for example, like this here, local minimum, local maximum. There are 4 turning points, but the highest is 2 pi, and which is also 2 pi. Lowest it is 0, and which is like this. This is just rough graph for your information. Okay, now question number 13. Now onwards the questions are different. You need to form the function. 13, 14, 15 till the last question. All are very, very important question. In every exam, either in 3 marks or 4 marks, you will find one of the question, right? So don't ignore now onwards. Now onwards, you will not be given such function. Function you will not be given. You need 2 forms of function from the given data. Okay, so let's see. Question number 13. Find 2 numbers whose summation is 24. So let numbers be x and y. Let numbers be x and y. Right. So it's obvious that here the other number has to be what? 24 minus x, right? Because the summation is 24. So one number is x, the other number is 24 minus x. That way you can write. Now what is asked? Whose product is as large as possible. So therefore, what's that product? Product equals to x into y, but we will reduce into the single variable. So x into, what is y? 24 minus x. So this is your function. Let this be fx, because this is purely in x now. Okay. Now what you are asked? Find the numbers. That means you get the x for which the function is maximum. As large as possible means what? This function should be maximum. We get x for which the function is maximum, right? We find x, that's the question. Once you get one number, the other number can be obtained very easily. We find x for which the function is maximum. Function should have maximum value, okay? So now it's like all earlier 12 questions. Up to this it is important, formation of the functions in all the remaining questions. Okay, so what we do? Obviously we differentiate it. Okay, how many times? Twice. So let's differentiate it twice. So what is f dash x? I'll just open first. So 24x minus x squared. So 24 minus 2x. I've just opened the function. Double derivative. That is, you have minus 2, this is 0. Then this is always negative. That means function will have which value? Here, negative, therefore the maximum value. Now for f dash x equals to 0, it implies 24 minus 2x equals to 0. So therefore x is 12. And if x is 12, if you put this into, double derivative, and here it is always negative, but just for your reference, it is minus 2 always, this is negative. So at 12, double derivative is negative. At 12, first order derivative is 0. Therefore, at x equals to 12, negative means maximum value. Function has maximum value. You are asked for that number, you are not asked for that maximum value. Got it? So no need to find what is f of 12. At 12, function has a maximum value that you have written from which information? Double derivative is negative, and at 12 first order derivative is 0. Got it? So one required number is 12. Therefore required numbers equals to 1 is 12 and the other one is 24 minus 12. Why? So 12 and 12. These are the 2 numbers whose summation is 24 and the product is highest. You can have many such numbers. You can take 20 and 4 also. Here product is 144. What's the product here? Just 80. You can take 21 and 3. But the product will be here 3 and 6, 63, here 144. That way, there are many numbers for which summation is 24. But if you take 12 and 12, then the product will be highest. Right? Got it? Understood? So in the 14th question, two positive integers x and y, you are given this, their summation equals to 60, and xy cube should be maximum. Okay, we want to get x and y. We find x and y, that's the question here. We find x and y such that xy cube is what? Maximum. That's a question here. So this is your function. So you need to reduce into the single variable. Either you can put the value of y or value of x, whichever you want to put. Choice is yours. Okay, so let here what I'll do, I'll put the value of x here, because to differentiate this become difficult also sometimes. So what is the x from this? That is 60 minus y, and this y cube as it is. So now this is expression of y, so I'll call this as f of y. Remember, you can put the value of y also, then this will be x as it is, and what is y? That will be 60 minus x, but your whole cube. This is easy to handle in differentiation, that's why we did in this way. Okay, we have placed x equals to 60 minus y here. You can do other way around also. Why we did like this? Because now differentiation becomes little bit easier, that's why we did in this way. So 60y cube minus y raised to 4. Now what we'll do? We differentiate it twice and we get the y. So let's differentiate it once. F dash y. What is that? It will be 180y square minus 4y cube. Okay. Then one more time derivative, f double dash y, which will be how much? 360y minus 12y square. Fine. Clear? What I did? I have just taken double derivative. I've just taken which derivative? Double derivative. Okay. Now what we do? We just put for first order derivative is equals to 0. It implies you have 180y square minus 4y cube equals to 0. You can take 4 common, you can take y square common. So we'll get the 45 here minus y equals to 0. 4 never be 0, y never be 0, because you are asked for positive integers. So 45 minus y should be 0. You know y never be 0 because you are asked for positive integer in the question itself. Okay, so y equals to 45. Now what you need to assure, this is a turning point. You need to show that at 45 double derivative should be maximum, no? So it should be negative. You are asked for maximum product. So I'll put y equals to 45 where? In the double derivative. Okay, so here 360 into 45 minus 12 into 45 whole square. Fine. What I did? I just need to assure that at 45 here the double derivative should be negative. That's what you need to show. So here I leave it for you. Just calculate this. It has to be less than 0. Right? So at 45 double derivative is negative. At 45 first order derivative is 0 because it is turning point. So therefore function has maximum, negative means maximum value at 45. You are asked for maximum product, just see the question, and therefore numbers are, you are not asked for the maximum value. If you are asked for maximum product, then you need to put x equals to 45 in the function, but that's not you are asked. So numbers are 45 and the other number is what? It has to be 60 minus 45, that is 15. These are the required numbers. So in the 15th question, it's like previous only. Find two positive numbers x and y. Their summation is here 35. This is given. X plus y is this. We want to get x and y here. This is the question. We find this such that, what's the condition here? The product is maximum. To find x and y such that, this is a question, such that x square y raised to 5, this is a function, is maximum. Okay, so what we'll do, like the previous question, we either convert x in form of y or y is in form of x. here x has a smaller power, so I think if you convert x in form of y, it will be easier. So what is x from this? 35 minus y the whole square into y raised to 5. This is in form of y, so I'll call that as f of y. F of y means what? Expression about y. What I did, I have just placed the value of x. What is x from this? 35 minus y. Now, like the previous question, you need to differentiate it twice. F dash y, I'll just do one time differentiation for you by product rule. So here this one as it is, here I'll use the chain rule. 2 times 35 minus y, derivative of x square is 2x, into by chain rule derivative of this, which is minus 1, and into y raised to 5 as it is, plus now 35 minus y the whole square as it is. What's the differentiation of this? That is 5 into y raised to 4. Now before you do the second derivative, you can find number of things common. The one is y raised to 4 you will find common. Then this factor also, 35 minus y also. So what will get inside the bracket? Y raised to 5 already taken common, this much already taken common, so here you are left with minus 2, plus we already taken y raised to 4 common, 1 power you already taken, so you are left with 35 minus y into 5. Now just simplify this and then again do the derivative, get f double dash y, simplify and get f double dash y, get this. Then for critical point, put f dash y equals to 0. Right? So you will get the values of y, maybe 1 or 2. But keep in your mind, you should have positive numbers. In case if you are getting negative, ignore it. Because in the question you are given positive numbers. Then put these values where? In double derivative. Right? One of them might be negative, the other one might be positive. Okay? You are asked for what? Maximum value. So get y for this f double dash is negative. That's your required value of y. Right? And once you get the y, once you get the one number, the other one can be obtained by writing 35 minus y. Fine? That way you can complete it. I leave it for you. Okay. 16th number. This is again same as like previous questions. Find two positive numbers. So here you need to take the numbers. Let positive numbers be x and y. Let positive numbers be x and y. You should have here positive, such that the summation is how much? 16. Okay. Now what you want to do? To find x and y, this is like earlier question, to find x and y such that sum of whose cubes is minimum, such that sum of what? The cubes. So x cube plus y cube, get their cubes first and then you add them, is minimum. This is the question. In earlier all questions you were finding for maximum, here you are finding for minimum. Okay, now like the previous question, this is your function. So at both the places you have same power, so I'll just reduce in x. What is y? That's 16 minus y is 16 minus x the whole cube. This is in form of x, so I'll call that as fx equals to x cube plus 16 minus x the whole cube. So now you get the double derivative as we did number of times, right? And complete it as we did earlier 2-3 questions. Okay, so this is for you.